We gonna get started. So the next part of our linear functions review. So kind of based on where we left off on the last part of the review, we left off with doing things with finding slope or rate of change. So now we're jumping over to finding y-intercept of a line. The first few slides here are not questions, or at least the first slide here is not a question. The first one here, finding the y-intercept of a line. Right? We can see the y-intercept of a line, right here. It's the point where the line crosses the y-axis. If we have the graph visually, we can find the y-intercept. Not a ton of math that goes into finding it. It's just, okay, where is this line crossing the y-axis? All right. So then, based on this, we have a question. Based on the graph to the right, what is the y-intercept of the line that is graphed? All right. Many of you guys did an excellent job. Let's see what the answer is. In this case, the y-intercept is 0, 5. It is the point where the line crosses the y-axis at 5. And we write that as the coordinate in the parentheses 0, 5. All right. Any questions? So the y-intercept of the line is also the point where x equals 0 in the table of values for the linear function. So in this example, we find the x value of 0 that goes along with the y value of 1, the y-intercept 1. So we're looking at a table where x equals 0, whatever that value of y is, right, that's our y-intercept. So let's do this one. Based on the table to the right, what is the y-intercept of the line? And again, please type this as a coordinate. So it needs to be in parentheses with the x value and the y value at the y-intercept. All right, so let's look at the solution. So based on this table, the y-intercept is at 0, 6. We're writing this as a coordinate. So we need to include the x and the y value. We'll go in parentheses with a comma separating the two values. The x value, 0, will always be listed first when you're writing coordinates. So we have the answer of 0, 6. Any questions? Okay. The y-intercept of the line can also be found in the equation for the linear function. The y value of the y-intercept is the value of the constant term. Okay, the constant term is the number that is not attached to a variable. So in this case, we have y equals negative 3x plus 1. The y-intercept is 0, 1. That the 1 there is the y value of the y-intercept. So then based on the symbolic rule to the right, what is the y-intercept of the line? Again, please write your answer as coordinates. All right. So, yeah, we go. The solution. Based on this equation, the y-intercept is 0, -3. The x value of the y-intercept is always 0. It cannot be any other number. Because the y-intercept, by definition, is where the line crosses the y-axis. The x value on the y-axis is 0. It cannot be another value. So the number here, the -3, only tells us the value of y. We already know the value of x is 0. The 5 is the slope. The 5 and the 3 don't do anything together as far as slope and y-intercepts are concerned, as far as those values are concerned. So anything I can clarify about this? Do you need to see an example? Do you need to see a better explanation? So next, so we had the characteristics of linear equations, which was our slope and y-intercept. How can we find those things between graphs, rules, tables? Now leaving that and going to the last part of what we talked about, which was solving linear equations. I'm going to do a few of these types of problems. Right? To solve an equation, it means to find the missing values, usually represented by a variable, that make the equation true. For example, in the equation 5 equals 2x minus 1, the value that makes this equation true is 3. So the solution is x equals 3. Right? 2 times 3 is 6, minus 1 is 5. There is no other number I can put in place of x that will make that a true equation. So we only have one solution, and that is x equals 3. Okay. One of the more common methods for solving equations is the balance method. This is what we've done in class. In this method, you rearrange the values in the equation by doing the same operations on both sides of the equal sign. Here we have an example that's been worked out. We start with the equation negative 25 equals 4x plus 15. We want to get x on one side by itself and a number on the other side of the equal sign by itself. And so we start by subtracting 15 from each side. And this is why it's balanced, because whatever I do to one side, I do to the other side. When we subtract 15 from the left-hand side, we get negative 40. When we subtract 15 from the right-hand side, the positive 15 gets canceled out, and then we're left with just 4x. We then have negative 40 divided by 4, and 4x divided by 4. Again, we're doing the same thing to the left-hand side and the right-hand side of the equal sign. And we're dividing by 4 because we're multiplying by 4 on x in the original equation. And division undoes the multiplying, and we're left with just a single x. Negative 40 divided by 4 is negative 10, and then we have that equals x. If I take the negative 10 and I put it back into the original equation, we'd have 4 times negative 10, which would be negative 40, plus 15 would be negative 25. So the solution checks out. And this is the primary method that we've looked at in class when solving linear equations algebraically. So then, find the solution to this linear equation. 3x plus 9 equals negative 18. And please write your solution as x equals whatever value you have found for x. Okay, let's look at the solution. Many of you guys did pretty good on this one. I see some kind of like common errors. Okay, so here it is. We get x equals negative 9. All right. For this, when you're finding a solution to a linear equation, you're no longer looking for a coordinate in this case. When you find the solution to a system of equations, that's when you have a coordinate as the solution, or you have the x and y value that you need for your solution. But for just solving a linear equation, it's just x equals. Right? We're finding the value of x that satisfies this equation and makes it true. Right? In this case, it is -9, because 3 times -9 is -27. -27 plus 9 is -18. Okay. All right, next. Right. Let's find the solution to this linear equation. 2x minus 7 equals 5. And again, write your solution as x equals whatever number works. All right. If you're still typing your answer, take the next couple seconds to finish it up. Here we go. So the solution is x equals 6. All right, we get this 2 times 6 is 12. 12 minus 7 is, in fact, 5. So 6 is the solution. For linear equations, there is always only, at most, one solution. Right? There will not be two solutions or two possible things that work. There will only be the one. There are equations that have multiple solutions. We're not there yet. That comes later. Lines, just one solution.